So the bell ringer was use the intercept slope method to graph the line y equals negative 3x minus 3. In order to graph, anytime you graph, remember you can always just make an xy table and pick values for x. Does it matter what values you pick for x? No, I probably don't want to pick 20 because I don't have room clear over here on my graph to go out to 20. So you want to pick smaller values. There's no fraction involved. Remember, if you have a fraction, you want to pick the positive and negative of the denominator and 0. If you have a fraction and then a whole number, because it'll get rid of the fractions for you. You'll get better at what values to pick. But we want to use the slope y-intercept format instead of picking points and plotting them. In the slope y-intercept format, we had two particular values. One of them was this negative 3. What did that mean? What was this first negative 3 right here? The coefficient of x. What did that stand for? It's the slope. And slope is rise over run. Rise over run is your slope. Then we had this negative 3 at the end, that constant. And what does that negative 3 stand for? You remember? Maybe did we take notes? Do you have this information down anywhere? Did you write that down the other day when we went over it? I know we talked about this because this is your notes that we did the other day. So the intercept slope form for an equation for a line is y equals mx plus b, where your slope is the m value and the b value stands for the y-intercept. Is that ringing a bell? Do we remember graphing at all? Were you not here? Oh, sorry, I said Friday. I meant Thursday. Wednesday because you had study hall on Thursday in here? So remembering from Wednesday is like being a little tough. You at least hopefully had that down in your notes, maybe? Didn't take notes? I can't help you there. I can put it up here and I can video it. I can post it. I can post the notes, but we went through and did this long process here. We talked about graphing an equation for a line and all of the steps, and do we want to go through those steps every single time? So we went through all those steps, and then we said, oh, there is another method that's quicker. And that quicker method is the slope-intercept method. You find a point, you count your slope. That's all you need to do. So we know that 2 points determine a line. One of those points can just be that y-intercept, and then we use the slope from there. So we talked about that format, y equals mx plus b. The coefficient of x is going to be your slope, and b is going to be your y-intercept, or the constant will be your y-intercept. Remember, it's rise over run when you talk about slope. So as we talk about slope, that's rise over run. So you're going to go 2 up and 3 over on the y-axis. So then we graphed this one, and we had rearranged it. So we said, well, if I want to graph this using the slope y-intercept method, I start with this y-intercept, which is 2. So we started there, and then we did the slope, and the slope was 2/3. So I'm going to rise 2. That's not probably the color I wanted. So you're going to rise 2, and you're going to run 3, and that's going to be another point for your line. Or you can go down 2 and to the right 3, rise over run, and that gives you another point, and you can graph it. We talked about a negative slope and how you can remember a negative slope. Just tell you right now, if a line rises up to the right, that's going to be a positive slope. and I don't know if you want to look at it as within the V, you can get a positive slope. If the line drops from left to right, that's going to be a negative slope. And I drew a line designating a negative slope. If you have a horizontal line is known as a zero slope. And then we have a vertical line. And when you have a vertical line, that's known as an undefined slope. So we have the 4 different types of slopes that you can encounter when you talk about graphing a line. Positive and negative is 0 and undefined. Sometimes the visuals will help you where you can actually create those lines within the words itself, especially the negative slope. So rise over run, you can lower and run as well. You just need to know which way to go so that you either get a point that's going to create that positive or negative slope. Then we will look at what creates a 0 or an undefined slope. Zero slope, you talk about your rise between 2 points. If I were to find 2 points on this 0 slope, how far up do you go? My rise. From one point to another, I do not rise any. How far do you run? I don't know, we'll just call that 1. What's 0 over 1? That's 0. That's why you have a 0 slope. But if I go to the undefined and I create 2 points, what's your rise between the 2 points? I'll call that a distance of 1. What's your run? How far over do you go between those 2 points? The run is 0. And what's 1 divided by 0? Undefined. That's why it's an undefined slope. Now, as you look at them, equations that will get you that undefined or 0 slope, 0 is going to be, if I look at this, all of my y values will have the same value, right? On a graph, all the y values would have the same. This could be the coordinate point 2, 3. This would be the coordinate point 3, 3. So the y values are the same, and your equation is going to be y is equal to some constant such as 3 for that particular example. So you don't have a slope and a y-intercept that you can really look at. There's just going to be a y-intercept. But if you look at the undefined, we can talk about these points. This could have the x point of 2, 3, and this would have the x point of 2, 2, or the coordinate point value, sorry. So if I look at it, x is always 2. That's going to be an equation that gives you a vertical line, is when it says x equals a number or x equals a constant. But otherwise, we just have the others. So back to the bell ringer, now that I've refreshed your memory a little bit about some graphing that we did, we want to first start with the y-intercept because that's a point. The y-intercept is actually a point. I could show it. It's the y value, so it's the coordinate point 0, negative 3. So I find out where it crosses the y-axis at, and I label that point. From there, I need to deal with my slope. Now, your slope is stated as negative 3. You put that as a fraction of over 1. So you can see your rise of 3 to a run of 1. So you go from the y-intercept, which was negative 3, and you rise 3. I'm going to go up 3, 1, 2, 3, and run 1. Do I go to the right or to the left 1 so that I get a negative slope? To the left. So I'm going to go to the left 1, and I'm going to get a point. Now, depending on your graph, I could go up another 3, 1, 2, 3, and back 1 and get another point. Or you go down 3, but then where do you have to go? To the right 1 in order to get your negative slope. You go down another 3 and to the right 1 to get your negative slope. Then you can go ahead and, oops, a little crooked, sorry, sketch the graph. You don't have to have all those points, How many points does it take to create a line? 2. It only takes 2. Just make sure you count correctly as you're going. So that was the bell ringer that we struggled with. Let's look at another example. You got the back side of that one. If I ask you to use the intercept slope method to graph the equation, the first thing you are going to have to do is get it into that y equals mx plus b format. To get it into the y equals mx plus b format, I need to solve for y. So you take your equation of 3x plus 4y, and you solve by moving the 3x over to the other side, and you get 4y is equal to negative 3x plus 12. And to finish solving for y, I have to divide by 4. Now, when you divide both sides by 4, those two can be written as separate terms divided by 4. It's like I'm taking both sides times 1/4, and if you take the right-hand side times 1/4, you use the distributive property, which makes each term divided by 4. So you end up with the equation y is equal to negative 3/4 x plus 3. Now you can make a big long table of x, y values if you wanted to, but it's a lot easier just to go here. Where are you going to start? You start with the y-intercept, or the constant, positive 3. Can you find that? I go from the origin and go where? Up 3. There's my first point. From there, I work with my slope. What's your slope? Negative 3/4. So from this point, I'm going to go up how far? 3. 1, 2, 3, and over 4. But I need a negative slope. So which way do you go to get a negative slope? To the left. 1, 2, 3, 4. There's my point right there. Or I can go down. I go down 3. 1, 2, 3. And which way? 4 to get a negative slope. To the right. 1, 2, 3, 4. There's another point. So if I connect them, there is the graph of your line. It's a lot easier than picking numbers, putting numbers in, and having to calculate it. Can you imagine coming up with an XY table for this? You would have to pick negative 4, 0, and 4 and find those values. See what you get. The two ladies can go. If you put negative 4 in, what's negative 3/4 times negative 4? What's negative 3/4 times negative 4? Positive 3. This is 12/4. So you get positive 3 plus 3, and you get a value of 6. Well, guess what? 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. That's that point right there. But would you rather find it by just counting 3 and 4? Or would you rather put it in here and work with fractions and calculate? I think it's easier just to go ahead and count your slope. Just go ahead and count your slope. Can I change the slide? Jack, can I change the slide? Okay. I can tell if you were writing stuff down. Are you serious? I have another example. All right, I'll come up with another example for you. Thought I had one, but I think we need another one because I think you struggled a little bit. Yeah, no more examples, so we'll go to number 9 in your homework assignment. Deals with this. I'll grab this real quick, and then I am leaving for the funeral, so you need to go to, well, I'll go ask Mr. Kidder what he wants to do. I didn't watch the class. Yeah. Now, Mr. Levine offered, he's only got 7 students, but I'm wondering by the time you guys pick up and go down there, you've wasted about 5-10 minutes, I'm guessing. So I'll see. All right, they ask you to graph 3x plus 4y equals 8. In order to graph, what variable do we have to solve for? Y. So in order to solve for y, I'm going to move the 3x over to the other side, which changes the sign. So I get 4y equals negative 3x plus 8. And as a final step, what are we going to do? Divide by 4. Or multiply by 1/4. Using the distributive property means that I'm going to take that times every single term on the other side. So I get the equation y is equal to negative 3/4 x plus 2. So to graph, where do I start? 2. You start with the y-intercept. It crosses the y-axis at 2. It could be any point. It's just that y-intercept is the coordinate point 0, 2. Now, what's your slope? Negative 3/4. So I'm going to rise how far? 3. 1, 2, 3. And I'm going to run how far? 4. Left or right to get the negative slope? Left. 1, 2, 3, 4. Or you can drop down 3 and go to the right 4. Connect the points. Please make sure you put the arrow tips on the top of them because it is a line. It is a line. Oops, should go with black. It is a line, so it does continue on in that direction. Man, I just don't have a very good line. There you go. There's the graph of your line. Slope y-intercept method is easier to graph, I think, than picking points. But whenever you're asked to graph a function, you could always pick points and graph. Does that refresh your memory from Wednesday? Yes. Okay, your assignment. Remember, what did I tell you you have coming up? Yeah, you have a test coming up. What I need you to do, you have a test coming up after 10. So what I need you to do for tomorrow is lesson set 8. And I've already done one for you. And now I'll go ask Mr. Kidder if he's going to come in here or if he wants you to go to Mr. Levine. So page 54.